Now we are going to read about the postulates of Bohr's model of hydrogen atom. It is an atomic structure. It is useful for examination of a intermediate public examination. So I think it is compulsory question, mandatory to read it. Postulates of Bohr's theory. See here, it is plus charge, and these are orbitals named as k, l, m, n, and 1, 1, 2, 3, 4. Electrons revolve around the nucleus in certain fixed circular path called orbits. These are orbits, and this is called nucleus. These are electrons, means in this orbits the electrons are present. Each orbit is associated with a definite amount of energy. Each orbit is associated with. It means some association of energy is present in the each orbit. Hence, these are also called energy levels. Not only orbitals, these are also called energy levels. These are designated as 1, 2, 3, 4 or k element. These are denoted or designated as 1, 2, 3, 4 k element. As long as the electrons revolve in these or orbits, they neither emit or nor absorb energy. Uh, as long as the electrons revolve in the orbits, they neither they neither emit or absorb energy. Hence, these orbits are also called stationary orbits. As there no emission or absorption of energy taken place, these are also called stationary orbits. Stationary means remain same. Now, what's fourth point? The new electrons revolve in those circular orbits, in which their angular momentum is integral multiple of h by 2 pi. Electrons revolve only in the circular orbits in which the angular momentum is an integral multiple of h by 2 pi. Therefore, angular momentum mv into r is equal to. It means what is linear angular momentum is also called is also denoted by r into linear momentum. It means position vector into linear momentum. Well, what is linear momentum? Linear momentum is mv. What is r? Position vector mv into r is equal to an integral multiple of h by 2 pi. N is n into h by 2 pi, where n is a principal quantum number, that is integral multiple. Integral, it is which is an integer. M is equal to mass of an electron. V is velocity of the electron. N is a principal quantum number. It's equal to 1 to 3. H is a Planck's constant. Planck's constant. Where when an electron jumps from a lower orbit to a higher orbit, it absorbs energy. When an electron jumps from lower orbit to a higher orbit, it means from K to L or L to M, etc. When an electron drops from higher orbit to lower orbit, it emits energy. It means from L to K and M to L, etc. It emits energy. The emitted or absorption is given by delta E is equal to E2 minus E1 is equal to HV, H nu or HV, H nu we call it. Delta E is equal to E2 minus E1 is equal to H nu. Delta is a difference in that energy. E2 is energy of higher order, E1 is energy of lower orbit. V is called as the frequency of emitted or absorption radius. As n value increases, the size and the size and the energy of orbit increases. Explanation of hydrogen spectrum. Hydrogen atom has only one electron and hence its spectrum is simple. When hydrogen has its subject When hydrogen gas is subjected to electric discharge, electrons absorb energy and goes to different higher order orbits. It is called excited state. Okay. Hydrogen atom has only one electron and hence its spectrum is simple. Hydrogen atom has only one spectrum and hence its spectrum is simple. When hydrogen gas is subjected to electric discharge, electrons absorb energy and goes to different higher orbits. It is called excited state. Hydrogen atom has only one electron and hence its spectrum is very simple. When hydrogen gas is subjected to electric discharge, electrons absorb energy and goes to different higher orbits. It is called excited state. What is called as excited state? When a gas is subjected to an electric discharge, electrons absorb energy and goes to different higher orbits. It is called excited state. But going to only higher orbits is called excited state. But an electron stays only for a small interval of time in the excited state. It comes back to the ground state either directly or through series. Here, going to higher orbit is called excited state. Coming to lesser orbit is called coming back to lesser orbit is called ground state. either directly or through stages. For example, when an electron is excited to fourth orbit, it comes back either directly or through steps. Direct steps 4 to 1. Indirect steps 4 to 3, 3 to 4 to 3, 3 to 1. 4 to 2, 2 to 1. 4 to 3, 3 to 2, 2 to 1. While coming back, it loses energy in the form of radiation. While coming back, it loses energy in the form of radiation. This radiation causes lines in hydrogen spectrum. Loses energy. It means while going it gains energy. It means it emits energy. It absorbs energy, emits energy while coming down. The reagent causes lines in the hydrogen spectrum. These lines are divided into 5 series. These lines are divided into 5 series. These series are named as Lyman series, Balmer series, Passon series, Bracket series, P-Fun series. Lyman series. When an electron jumps from any higher orbit to first orbit in UV region, Lyman series is formed. When an electron jumps from any higher orbit to first orbit in UV region is called as Lyman series is formed. Balmer series. When an electron jumps from any higher orbit to second orbit in visible region, Balmer series is formed. When an electron jumps from any higher orbit to third orbit in near infrared or IR region, Fashion series is formed. Bracket series. When an electron jumps from any higher orbit to fourth orbit in the middle IR region, bracket series is formed. When an electron jumps from any higher orbit to fifth orbit in far IR region is called P-Fun series. See, we can see it in the Lyman is in UV, Rahlmann in visible, Lyman UV, Ly U, Ly, Balvis, Balvis, Fashion near air, middle air, far air, UV visible near air, middle air, far air, UV visible near air, middle air, far air, Lyman, Malmer, Fashion bracket series for FIFAN. Here N1 is equal to 1, 2, 3, 1, 1, 2, 3, 4, 5. It means it is first orbit, second orbit, third orbit, and N2 from it means from higher orbits are 2, 3, 4, 5, etc. like that. The wave number or wavelength of a spectral line in the hydrogen spectrum can be calculated by Rydberg's equation. Rydberg's equation is nu is equal to 1 by lambda. It means frequency is equal to frequency is equal to 1 by wavelength is equal to RH is equal to 1 minus n1 square by 1 by n1 square minus 1 by n2 square 1 by n1 square minus 1 by n2 square. Nu is equal to 1 by lambda is equal to RH into 1 by n1 square minus 1 by n2 square. Electron transition in hydrogen atoms. You can see this from 7 to 1, from 6 to 1, from 5 to 1, from 4 to 1, 3 to 1, 2 to 1. From 7 to 2, 6 to 2, 5 to 2, 4 to 2, 3 to 2. Here energy decreases. It means energy decreases. Here energy is more. This is Lyman series, Balmer series, UV visible near air, middle air, far air. See like this and see it. Okay, this question completes. Okay, very easy. So I conclude by saying that no fucking guy should send any message that this video is very bad like this. If you send so, I'll kill you. Okay.